let's look at some examples of how we would use this measure of concentration. So let's say that we were making a solution and we wanted to find its molarity. So again, looking at dissolving salt in water, let's say that we had 31.26 grams of sodium chloride. This would be a heaping spoonful of salt, and if we were to stir that into a glass of water and then measure the volume of the solution that we get, let's say that we found that our solution had a volume of 126 milliliters. If we wanted to find the molarity of this solution, molarity is defined as the amount of solute divided by the volume of the solution. And we just need the amount of solute to be in moles and the volume of solution to be in liters. So we know the number of grams of sodium chloride, so we would first need to convert from grams to moles, dividing 31.26 grams by the molar mass of sodium chloride, 58.443 grams per mole, gives us an amount of 0.53488 moles of sodium chloride. And then the volume of our solution, 126 milliliters, dividing that by 1,000 milliliters per liter, gives us a volume in liters of 0.126. So now we've got an amount of solute in moles, we've got a volume of solution in liters, and we can just divide these. Our molarity is going to be 0.53488 moles divided by 0.126 liters, and dividing this through gives us a molarity of 0.42451 moles per liter, or rounding off to an appropriate precision. Our precision here is determined by the three significant figures in our solution volume, and so that is, we round off to three significant figures, and our molarity would be 0.425 moles per liter. So the unit on molarity is mole per liter. You'll often see this written as just a capital M. Sometimes the M will be in italics, sometimes the M will be in small caps. All of these are used to represent the unit of molarity. My own personal preference is to use moles per liter. The letter M is often used to represent the quantity of molarity, and I personally don't like to use the same symbol for both a quantity and the unit for that quantity. And so I like to use capital M. I'll usually italicize it, and then I use that for the quantity that represents molarity, and then for the unit I will typically use moles per liter, just to avoid any confusion. And this example also is typical in that when you're working with solutions of solutes dissolved in water, typically the molarity value is going to be less than 1. You can have solutions that are more concentrated than 1 mole per liter, but most of the time it's going to be less than that. Just to give you a sort of a frame of reference for these numbers here. So let's look at how we would use molarity to find the amount of solute that's dissolved in a solution. So let's say that we had a sample of the salt solution that we just made, and we want to find out how many moles of sodium chloride are in there. So this sample has a volume of 40 milliliters. If we want to know how many moles of sodium chloride are dissolved in that 40 milliliters, we would need to know the concentration of the solution, and we just found that. That's 0.425 moles per liter. And here I'm using the capital M to represent the unit of molarity. Even though that's not my preference, that's often how you're going to see it done. And so I'm going ahead and using that in this problem. So the molarity of our solution is defined again as the amount of solute divided by the volume of solution. And if we want to find the amount of the solute, that is the number of moles of sodium chloride, we can rearrange this formula by multiplying both sides by the volume of the solution. And so that gives us that the amount of solute is equal to the molarity times the volume of solution. And so plugging in our numbers here, we've got a molarity of 0.425 moles per liter. The volume of our solution is 40 milliliters. Now, before I proceed here, molarity has units of moles per liter, and the volume of solution that I've got here has units of milliliters. So if I were to multiply these quantities right away, the units are not going to cancel out properly. We've got liters in the concentration part, and we've got milliliters in the volume part. So if I want my units to work out, I need to convert from milliliters to liters. And I can do that simply by adding in a conversion factor. 1 liter is 1,000 milliliters. And so if I set that up as liter divided by 1,000 milliliters, now my units will work out. The liters will cancel, the milliliters will cancel, and plugging these numbers into a calculator will give you that the amount of dissolved solute in this case is 0.0170 moles of sodium chloride. So this is one way to work out the answer to this question using the formula for molarity. Another way to do this is you can think of molarity as giving you a conversion factor between the volume of the solution and the amount of solute. And so if you want to approach the problem this way, one way you could think about it is that you've got the number of milliliters of solution. Molarity will give us a way to convert from liters of solution to moles, and so we would want to convert from milliliters to liters using a conversion factor between liters and milliliters. And then once we have the number of liters, we would want to divide by liters and multiply by moles, and so we would use our molarity, moles of solute relating to the liters of solution. We'd use that as a conversion factor, and when we multiply all of this together, we will get the number of moles of our solute. So putting in numbers into these quantities here, we would have 40 milliliters of solution, multiplied by our conversion factor from milliliters to liters. There's 1,000 milliliters in a liter. And then multiply by our conversion factor between liters of solution and moles of solute. We've got 0.425 moles of sodium chloride in a liter of solution. So now if we multiply this all out, again, our units cancel, and we end up with the same answer, 0.0170 moles of sodium chloride. So mathematically, these two approaches to solving the problem are equivalent. Which one you use really doesn't matter, and it's sort of a matter of taste or personal style, and I will tend to use one or the other depending on the situation. Whichever method feels more natural is what you should use. Okay, so let's look at one more example. Let's use molarity to find the volume of a solution. So let's say again that we've got our solution of sodium chloride with a concentration of 0.425 molar. That is 0.425 moles per liter, and we want to know what volume of that solution we would need if we wanted to have 0.030 moles of sodium chloride. So here, our formula for molarity. Molarity is the amount of solute divided by the volume of solution. Here we want to know the volume of the solution, and so we can rearrange our formula. We can multiply both sides by the volume of solution. Then we can divide both sides by the molarity, and so that gives us that the volume of our solution that we want is going to be the amount of solute divided by its molarity. And so we would put in our two quantities. The amount of solute is 0.030 moles. Our molarity is 0.425 moles per liter. And now our mole units cancel, and we end up with units of 1 over liters, and so that is 0.071 liters of solution. And that is the volume of solution that we would need. Now, if we were going to be measuring the solution using a typical graduated cylinder, graduated cylinders are usually calibrated in milliliters rather than liters. So if we wanted to convert this volume into the number of milliliters that we want, we would simply take this volume in liters and multiply by 1,000 milliliters in a liter, and that would give us 71 milliliters of solution is the volume that we would want to measure out. Now we can do, again, we can use molarity as a conversion factor to give us a different way to approach this problem. And when you're using the conversion factor approach to a problem, you need to be, it can be a little tricky. You need to be really careful about thinking about what is the conversion that you want to do. What do we want to? We want to convert from something to something else. And in this case, we want to get 0.030 moles of sodium chloride. And so what we want to know is, we want to know what volume of solution is equivalent to this amount of solute. In other words, we want to convert this target amount of solute, the 0.030 moles, we want to convert from that number of moles into a volume of solution. And so just thinking about this conceptually, we're going to want to convert from moles of sodium chloride, and then using molarity, we can convert from moles into liters of solution. Molarity relates the number of liters of solution with the number of moles of solute, and then we could convert from liters of solution to milliliters using the conversion factor between those two units. And if we multiply this out, we would get our answer in milliliters of solution. And so then plugging in the numbers into these conversion factors, we have 0.030 moles of sodium chloride. 1 liter of solution contains 0.0425 moles of sodium chloride, and then 1 liter is the same as 1,000 milliliters. So multiplying all this out, again, our units will cancel and we'll end up with our 71 milliliters of solution. So just another way to approach this problem. We can work with the formula for molarity, or we can treat molarity as a conversion factor. Either approach will work, and either one is totally fine. So to summarize these relationships involving molarity, molarity is defined as the amount of solute divided by the volume of solution, and so it has units of moles per liter. And one way that you can represent a formula like this as a sort of as a mnemonic device for keeping track of these relationships, one thing you can do is you can write this as a triangle with the amount of solute, the number of moles on top, that's usually represented by the letter N. The molarity is the concentration, represented by capital M, and the volume of solution represented by the letter V. Now, the way to use this little triangle mnemonic device is, if you want to calculate the molarity M of a solution, you would divide the amount N by the volume V. So molarity is the amount divided by the volume. And in this little triangle here, the N is over the V, and so that reminds us that we want, in order to find molarity, we would divide amount by volume. Similarly, we've seen that the amount of solute, if we want to find the amount of solute, we will multiply molarity times the volume of solution. So again, taking our little triangle mnemonic, if we want to find the amount, that's N, we would multiply the molarity m by the volume v. So n is equal to m times v. Or the third example that we looked at was that the volume, if we want to find the volume of solution, we would take the amount of solute and divide by the molarity. So again, with our little triangle mnemonic, if we want to find V, we would divide the amount N by the molarity M. So some people like using mnemonic devices like this. Some people don't. Your mileage may vary. But if this is something that's useful for you to keep track of how these quantities are related, then I say go for it. Anything that will help you keep this stuff straight is a useful tool to have in your toolbox. Now, before we leave the topic of solutions and molarity,